Hello guys, this is me from Chalk and Duster. Today we will discuss the chapter matrices. A matrix is defined as a rectangular array of m n numbers arranged in m rows and n columns where m and n are positive integers. Okay, first we will discuss some terms related to matrix. First of all, how we denote matrix. A matrix is denoted in this way, like we write A or like this. Aij m cross n. Okay, and this is matrix of order m cross n, and each individual number is called entries, component or element, like this one or this one. These are nothing but element, or we may call them as entries or component of matrix. Here it's written like Aij. Here Aij, this is nothing but index. This we call as index, and I denotes the row number and j, this denotes the column number. Here we have written this matrix in square bracket. We can either choose this square bracket to write this matrix, or this curved bracket, or this symbol to denote this matrix. And here we define a new term, submatrix. So what a submatrix is, suppose you delete this row and this column passing through this element a11, then the matrix left after deleting this row and this column, this is termed as submatrix. Obviously you can find some matrix of some other element, like you delete this row, you delete this column, then this one, the matrix left. This is submatrix. This is normally the submatrix. This is how we define submatrix as. Okay. Now there are different types of matrix based on different bases. Okay, like this you can see we define rectangular matrix. You remember how we denoted a matrix as Aij m cross n. If m is not equal to n, then we define this matrix as rectangular matrix. And we also define horizontal matrix. Horizontal matrix, for horizontal matrix n is greater than n. Do remember this, n is greater than m. Similarly we define vertical matrix. For vertical matrix, m is greater than n. Okay, if either of number of rows or column, if this is equal to 1, this implies that matrix is termed as vector. Okay, suppose if m is equal to 1 and n is greater than 1, then this is our row matrix or row vector. Okay, and consider the case where n is 1 and m is greater than 1, then this is our column matrix, or we can also call it as column vector. Okay. Now we define a square matrix, and this is very important. You can see that whole matrix is based on this concept only. Okay, we'll see it later. For a square matrix, m is equal to n, that is the number of rows and number of column both are equal. Okay. For a square matrix, we define one term, what? Conjugate pair of elements. What it means after all, a conjugate pair of element, this one, Aij and Aji. These are conjugate pair of element. A12 and A21, this is conjugate pair of element. Or take anything, A35 and A53, these are what? Conjugate pair of elements. Okay. And these terms, A11, A22, A33, these are diagonal elements. Remember my words, these terms like diagonal element or conjugate pair of element, these are defined only for a square matrix. And the line along which this diagonal element lies, this is termed as principal diagonal or main diagonal or leading diagonal. I am talking about this line. Here it lies A11, A22, A33 and so on, and here lies other element A12, A13 like this, and here lies A21, A31, this. So this line is our main diagonal, and this and this, these are diagonal elements. Okay. And further we define, this is also for a square matrix, we define singular matrix. What is a singular matrix? If determinant of A, this is 0, determinant of A 0 implies it's a singular matrix. Else if determinant is not equal to 0, this is a non-singular matrix. Okay. And I hope you know it very well that determinant is only defined for a square matrix. Then we define one another term, trace of a matrix. What is trace of matrix? Trace of matrix is nothing but summation of I from 1 to n. Let me write it in general terms. It is A11 plus A22 plus A33 plus A44, that is sum of diagonal elements lying along main diagonal or principal diagonal or leading diagonal, whatever. Okay. Then we define a new term, singleton matrix. I hope this is clear from its name only. For singleton matrix, there is only one term, only one element in the matrix, that is m is equal to n is equal to 1. this is our singleton matrix. Okay, then we define diagonal matrix. This is also clear from its name that for diagonal element, see, this is a diagonal element. This will have non-zero elements only along this principal diagonal, that is the element lying along this principal diagonal, that is non-zero, and rest all other elements are 0. All other elements are 0. We can write this in general term that Aij this is equal to 0 for all I not equal to j, and Aij may or may not be 0 for I equal to j. That means this may be 0 or this may not be 0. Okay, we can denote this matrix, this diagonal matrix, in some other way, like this only. Suppose if this element were suppose this were d1, d2, d3, d4 and so on, so we can represent this matrix as diagonal diez d1, comma d2, comma d3, comma d4 and so on. Okay, after diagonal matrix we define another matrix, scalar matrix. Scalar matrix, this itself is a diagonal matrix. The only specification is that all the diagonal elements are equal, that is d1 is equal to d2 as d3 as d4 and so on, and this is equal to some another constant, let's say d. Okay, so this is our scalar matrix d 0 0 0 0 0 0, again d 0 0 0 0 d 0 0, like this. This is a 4x4 matrix, and similarly the scalar matrix can be defined. In general terms we can write it as Aij this is 0 for I not equal to j, and d for I equal to j. Okay, it's okay. And then we define unit matrix. This unit matrix is itself a scalar matrix. Okay, the only difference is that in this case d is equal to 1, or in general terms we can write it as Aij this is 0 for I not equal to j, and 1 for I equal to j. Okay, then we define triangular matrix. Triangular matrix, we are having two type of triangular matrices. Two type in the sense this one upper triangular matrix, and second obviously lower triangular matrix. And let's see what are they. For upper triangular matrix, the elements above or on the main diagonal are non-zero, and the rest of them are 0. Okay, let me show this through an example here. You can see it. Okay, so this was our principal diagonal or main diagonal, and below this all elements were 0. Above this all elements may or may not be 0, and diagonal elements they may also may or may not be 0. So we can write this in some general form that Aij this is 0 for all I greater than j, and for others it may or may not be 0. And other was what? Lower triangular matrix. For triangular matrix, consider this one: -1 0 0 5 6 0 3 2 0. Again, this was our main diagonal, and above this all elements are 0. You can see here these all elements are 0. That is, here ai is equal to 0 for all I less than j. You can see that one of the diagonal element is 0. As I said, these elements may or may not be 0. The only compulsion is here in this, that the all elements have a principal diagonal that must be 0. Then we define another matrix, null matrix, or you may call it as void matrix, whatever. For this, what is the case? All elements are nothing but 0. All elements is 0. Okay, so here we complete the definition part. That is, definition part over here. Now we'll see next part. We will see in another video. Thank you so much. Hope you have liked this. Thank you very much.